Alright, so we talked about the basic layers of the skin, and we did get through the first two superficial layers. So we talked about the epidermis and dermis, which together makes up the cutaneous membrane, aka your skin. Now below that we have the hypodermis. So the hypodermis is below the dermis. Makes sense, right? So let's talk about the hypodermis. So what we see is that instead of being dense irregular connective tissue, it's actually loose connective tissue. And more specifically, the two main tissues or types of tissues that make up the hypodermis are that very open, like more fluid areolar connective tissue, which has very few fibers, a lot of ground substance, and also white adipose tissue. So this is where you find a lot of that, what we call subcutaneous fat. So this is why you have all that yellow colored, like this blobby corn-like looking thing we see in the hypodermis. That is fat. So if you've been ever unfortunate enough to get a wound that's very deep, and it definitely needs stitches if it's that deep, you might have been able to see that kind of like a yellow corn-like substance. That's why like a lot of people describe it as, and that is the underlying fat below your cutaneous membrane. So this is what we call hypodermic fat or subcutaneous fat. And the cool thing is that what we have is that, or if you're into fitness, this is the one that people are trying to shed when they're trying to get super ripped for like bodybuilding or fitness competitions. So the subcutaneous fat adds the bulk and also covers up, if you're really into working out, that's what covers up the muscles as well. And this is what we see. Now, is this scientific? Not necessarily, it's just something I pulled up from the internet, but it just shows you like, okay, there's different ranges of sub-Q fat. But the less sub-Q fat and body fat percentage you have, you start to see more of the underlying structures below the subcutaneous fat. So you still have your cutaneous membrane, but with less white adipose, you have less packing and less material covering up things like your muscle and all the fascia underneath. So that's what we have with like sub-Q fat. Or this guy right here, like look at this. I mean, he's super shredded, and it's kind of funny, his glutes look like pecs. I mean, he has like very little subcutaneous fat here, so that's why you see all the striations, because without the unfortunate white adipose doesn't have much form or function, or not function. It doesn't hold its shape as well as skeletal muscle. That's why, like, but yeah, you can definitely see the fascicles and striations in his skeletal muscle over there. Yeah, that's crazy ripped, right? So the integumentary system is more than just covering things up. We covered in the previous lecture slides, that it has an important role in making vitamin D production. Again, that UV light actually becoming beneficial in that aspect. And general functions of vitamin D, like one big one is calcium absorption for your bones. So it's also important for bone strength, and even though it's your skin, it kind of helps out your bone mineral density. But we could talk more about that in the next unit. And then it also has that protection function. So we did talk about the keratinization. So even though we have a lot of keratin in things like our nails that protect the ends of our fingers, or like in animals, they have the antlers and horns, but it also forms a barrier between the outside and the inside of your body. So it does have that hydrophobic and some mechanical protection as well. And also, so we didn't talk about those other ones. So sensation detection. So your skin is very sensitive. That's why you can feel when something's touching you, or if something like a bug is crawling across your skin. This is why you can feel things. Temperature regulation is also very important. So your skin is very important in cooling yourself off, and also like retaining heat as well. And then blood storage as well. So again, you have all this blood vessels, and if you look at the diagram of where the blood vessels are, you see that they kind of extend throughout the dermis and hypodermis. So it's actually very useful in terms of providing a reserve for the blood as well. Actually, these two go together. And excretion, secretion. So we're going to cover, like, the integumentary system is more than just your skin. There's also a lot of glands in your skin. So what happen if your skin wasn't there? Say the technical term for this is degloving. So this is what it would look like if your skin wasn't there. Your skin is an important barrier, and I think this is maybe Body Worlds, or they had the knockoff coming here the other like maybe several years ago. But yeah, this is, if you're ever been to one of these exhibits, so this person here is holding all their skin. So if we didn't have our skin, all of this muscle and all this like fascia and all this connective tissue would be exposed to an environment. So this is what we look like without all that skin and sub-Q fat. Now, so it's very important as a barrier, because again, if you try to walk around with like, or where did I see that? There was a cartoon where someone was like inside out, and then every time they took a step, they would leave a trail of blood because they didn't have any more skin. So yeah, it's pretty gross, right? So what we have here, so if you've ever been to a cold, very cold area, what happens if you don't have enough insulation? And what happens to your extremities, especially your fingers and toes? Well, you might notice that they start to lose their color. And if it gets really bad, then you might, you might end up with frostbite. So what happens is that what is causing that red color in the rest of these fingers, but there's no color in her middle finger and her pinky over there? Yep, so this frostbite, right? So this is, why does your skin lose its color? Well, it's the same thing as it's linked to another question as well. Why do some people get hot and red in hot climates? And what we have here is, okay, so this is disclaimer. This is actually showing the East Asian alcohol flush reactions, or what we sometimes just call Asian glow or Asian flush. But this is what we have, but it's kind of similar. What's happening is that we have, instead of getting paler, now you have someone's skin getting redder. So this is the underlying reason why we have this redness being lost when you're cold, and why you get more red when you're hot. It's due to, or if you have something like this, it sometimes shows up like that. Like for me, I have rosacea, and two common triggers of rosacea are heat and sunlight. And where do we live? Yeah, somewhere where there's a lot of heat and sunlight, so kind of like screwed up. Yeah, I'm kind of like, oh, who's the loser in that aspect? Me. But that's a big thing about the skin. It's important in regulating temperature and also storing blood, so the two go hand in hand. So what we see here is that you have all these blood vessels, major blood vessels, or venules and arterioles here in the hypodermis, but you also have these arteries and veins and venules and arterioles. And then they end up in little capillaries over here. So you have all this network of blood vessel that runs through the lower, deeper hypodermis and the dermis as well. So they carry blood, but they also, what is the major fluid component of blood? Plasma, but plasma is mostly water. So water absorbs heat. So this is why when you mist yourself with a spray of water, this is why you feel cooler. And this is why, if you have a pool, you notice it kind of retains water, or bodies of water, or when you boil something, it takes a while for to actually evaporate, right? So water carries temperature, absorbs heat. So what's one way your body can cool itself off? Is maybe put that heat and that water and blood closer to the surface of your body. So if all this blood ends up closer to the surface of your body, that makes it more exposed to the environment. So all the heat in your blood is now being lost through to the environment, because you're pushing it closer to the surface where it can escape to the environment. So this is why when people who get to flush in hot climates, this is why they get redder, like me. If you ever see me in person, sometimes I have red splotches due to my rosacea and also the heat reaction. But same with frostbite. It's also linked to this blood storage and temperature regulation as well. So this is why we saw that if you see someone who's getting prone to frostbite, or if you're in a cold environment for a while, this is why we see the extremities, especially the parts that are distal from your trunk. These are the first to get white because they start to lose blood, or what your body does is kind of squeeze these little blood vessels, and by squeezing them and causing them to constrict, this pushes the blood closer to your body. Thing is that if you're in a cold environment, do you want to lose the heat from your blood to the environment? No, you want to keep yourself warm, right? And which is more important, the tip of your finger or your internal organs like your heart, your liver, your kidneys, your lungs? So again, your internal organs are more important than just the tip of your fingers. So this is why if you're in a cold environment, you start to lose, but your body tries to shunt the blood from the extremities to your internal organs, and especially this very important organ over here. Okay, so then what we have is that that red blood cells over there. So the red blood cells. So why are red blood cells red? I mean, they're definitely in blood and they're red, but a big important part of red blood cells is that they have this compound called heme, and heme is actually part of a larger polypeptide, or remember quaternary structure, so you have multiple polypeptides. So this is a very important protein called hemoglobin. And the heme in hemoglobin is what gives the red cut, and especially this iron atom at the center of heme. Now, I want you to know this clover leaf pattern of heme. Just recognize it. I mean, there's many structures that look like that, but just know that heme has iron, and this is the reason why your red blood cells are red. So this is why, like when someone's is in a hot environment, that's why they flush and turn red. It's because of all the blood vessels opening up and bringing more blood to the surface. So more blood to the surface means more red blood cells to the surface. That's why people appear redder. Conversely, when it's very cold, all the blood gets brought more toward the inside of the body, and that's why we see that the extremities start to get pale. And this is why we get frostbite if we're exposed to the cold for too long, because I mean, it's not just about the blood and the red color and heat, it's also the oxygen and nutrients in blood. So if the tip of your finger doesn't have any blood flow to it, what's going to happen to the cells? They're not going to have any oxygen, they're not going to have nutrients. So if you're exposed to the cold for too long, you might start to lose the cells here, and if it gets worse enough, you might have to amputate that part where all the cells have died. So this is why hemoglobin is also part of skin color as well. Now, what we have here is perspiration, aka or sweating, as you probably know it. So there are two main types of perspiration. We have the insensible perspiration and the sensible perspiration. So sensible perspiration is like when you're sweating and maybe you're exercising or you're outside and it's like 90 something degrees, and those are the beads of sweat that you can feel trickling down your forehead or your face or body. But insensible perspiration, you're always sweating to some extent, but such a tiny amount that you can't really feel it with all the nerve endings in your skin. But they're all perspiration. So again, this insensible is the one you don't notice, but you're kind of always doing in the background. Sensible is when you feel that sweat rolling down. And what causes that perspiration? It all deals with these glands, and there are many types of glands. I'm going to cover general categories in this last lecture before the exam. So we have excretion and glands. So eccrine or merocrine sweat glands. So we did cover in the tissues about different types, like what merocrine means. But eccrine sweat glands are located almost everywhere. So a nice mnemonic I was taught was like eccrine is everywhere. So it's almost everywhere, but practically everywhere. So you have where their skin, except for very few places, you have eccrine glands. And what are they doing is secreting this watery secretion, and it does have some salt as well. So why is sweat salty? It's due to these sweat glands and this watery secretion. But the thing about sweat being salty is not just providing flavor. It's also due to osmosis, because what happens if you put a very salty solution outside of a cell? Well, that's going to draw water out, right? So if your eccrine sweat glands are secreting something that's salty, that's going to draw water outside of your body. But what about that water outside of your body? What is it going to do to the heat of your body? Well, that water is going to absorb heat, and it's going to cool yourself off. Because this is why these are very important in thermal regulation, especially in hot environments, because if you bring more water to the surface of your body, that allows it to absorb heat, and when it evaporates, that heat evaporates with the water as well. Let's see, if there was a 9:30 live stream plan for this morning, that might be a YouTube thing. So there's class time is 1:30 to 2:30. I mean 1:30 to 2:20. So whatever that was, no, class isn't at 9:30. Okay, so that whatever you saw on YouTube, it's always, unless all the live streams are 1:30 to 2:20 unless it's an exam day, or starting next week, this is when like the med students start their second unit that I'm co-director of. So this is where sometimes I have to do something at the medical school, and it does overlap with the class time. I will pre-record that, but I'll also let you know in advance when I'm doing that. So that's what we have there. Okay, so apocrine sweat glands. So this is another type of sweat gland, but instead of being watery like those eccrine or merocrine sweat glands, they produce the sticky and cloudy secretion. And actually what makes it sticky and cloudy is all these fats and oils and lipophilic compounds. So what we have is that secretions and actually proteins as well. So the secretions break down, and if you ever had like or if you ever tasted like cooking oil or butter or lipids, and then it starts to rancid, you may be like, this tastes a little old and kind of tastes funky. Well, same with lipids. When they're broken down with bacteria, they can often form smelly compounds. And what happens is that these apocrine sweat glands, we all have them, but it's only after we undergo the changes that are associated with puberty that these become active. So, I mean, yeah, little kids can be smelly, but like once we're teens and older, we have a different type of smell. That's due to these apocrine sweat glands. And where do you find them? Well, unlike the eccrine sweat glands where you find almost everywhere, apocrine sweat glands are found in specific areas. And I mean, not throwing us my fellow guys underneath the bus, but I love this meme, not because it's funny, but it's because it actually shows you, okay, where are the oiliest and smelliest parts in our body? And I like it because it's like, okay, this is where we find apocrine sweat glands. We find them in the armpits, we find them in the groin. And just for the completion's sake, let's add the nipples to this diagram over here. So I like this diagram because it shows us where typically the smelliest parts are the parts we really have to wash thoroughly with soap so in order to not get smelly. And it's these parts right here, and what's causing that? Those apocrine sweat glands that are broken down by bacteria into these smelly compounds. But maybe some people don't wash that part, but yeah, so that's so eccrine, that's the one that secretes the watery secretion and very important in regulating our body temperature. But apocrine, that's the one that's important in secreting those very waxy and or those smelly compounds and those sticky substances. Okay, let's talk about another special type of glands called sebaceous glands. So sebaceous glands, these are connected to the hair follicles, and this is a hair follicle over here. And what we have are these sebaceous glands that are right here. So this isn't where the hair root is, but it's connected to that whole part apparatus over here. And what they do is that as the hair grows, they secrete oils that help to lubricate and condition the hairs in our skin. Now, sebaceous filament. So what happens if you allow sebum? So they secrete this substance called sebum that's oily and waxy. Now, what happens if this sebaceous filament or the sebum builds up in this hair shaft, along the hair shaft and root? Well, you might get something like this. But I love this clip because look at that when he pulls it out. You can see that little hole, that little crater. So that was a pocket where that sebaceous filament was. So that thing he pulled out, that oily, that yellowish, waxy looking thing, that is a plug of semen, or plug of sebum. Big difference. Yeah, so that's a plug of sebum. So sebaceous filaments, that's what we have there. So yeah, I love this one because they have the plug right there. I know if you like Dr. Pimple Popper, I love these videos. Like, oh, I love that one, even though it's kind of gross. It shows that little crater. It's like so perfect. I don't like the ones where people pop and it's like oozy and weepy, but yeah, that's kind of gross. Okay, so what we have here, so sebaceous glands, sebaceous gland. What the hell is that? I have to use another one, but yeah. So what we have here is like. So what we have here is that all the sebum is building up, and then we have over here is that, okay, now the sebum is building up, but instead of forming a filament, this is kind of trapped by that pore where the hair shaft is exiting, right? So what happens if these sebaceous glands remain plugged? Well, notice that this is becoming raised and it's pushing up the epidermis. And if it starts attracting a lot of like inflammation and blood to the area, this is what we might see with acne. So this is something that can result from these sebaceous glands And if you're producing all the sebum, and instead of the sebum going out to the surface and oil and providing oils for the hair and the surface of your skin, this is why we can encounter this what we call comedo in dermatology. But if you think that's fascinating, like, I mean, yeah, that one's pretty chunky. So I don't like the one where it's like weepy and it has all this, like, it might be infected with bacteria. That one it's just like glandular secretions. But what we have here are sebaceous glands. But what happens if this sebum builds up, but there's no eruption of that sebum out past the epidermis? Well, this is what we might have with the epidermoid cyst. Or sometimes we call, or in this case is when it develops from a sebum gland. That's what we call a sebaceous cyst. And so what she did is actually cut this layer, and this is what she was squeezing out. She was squeezing out all that trapped sebum. And if you ever smelled like or just remember like my previous example, how when butter or lipids or oils or frying oils get rancid, they kind of taste funky. They also smell funky too. So this is why if you've ever seen some like sebaceous cyst lance or had one lance, then it kind of like has that smell. That's due to all those oils and waxes. Or another example, like grease traps if you ever worked in the food industry, like grease traps have this unholy smell, and it's due to the bacteria breaking down those compounds, especially fatty ones. Same with sebaceous cysts. So oils, when they get broken down by bacteria, they tend to smell pretty bad. Yeah. So why do hairs need sebum? Again, that waxes and oils. It's your body's natural conditioner, but if it builds up too much, it can result in things like the acne we saw and the sebaceous cysts. All right, so yeah, okay, that's enough of that for now. But there's other special glands. So these are exocrine glands, and they are special glands that lead to the surface of our skin. Mammary glands and ceruminous glands. So where are mammary? The mammary refers to the chest, right? So here we have the mammary glands, and don't worry, the pixelation is just for YouTube and Twitch. Yeah, the uncensored one is in the slides. But what we see here is that, okay, mammary glands, they produce, this is during lactation, especially when a woman is pregnant, or postpartum, after pregnancy as well. So this is what mammary glands, they produce that milk. So do men have mammary glands? Yes, we do have mammary glands, but the thing is that in the typical male, the mammary glands aren't going to be as developed because we didn't get the hormones like estradiol and progesterone that surge during puberty in females. So in a male, a mammary gland will be the size like maybe just behind the areola nipple, but it's underdeveloped. So this is why when some people are into bodybuilding and they take a lot of anabolic steroids and testosterone and it gets converted to estradiol and other hormones that promote breast growth, this is why sometimes they actually literally grow additional mammary gland tissue that causes these puffy nipples because they start to build up that mammary glands. Yep. So yeah, men, the gynecomastia. And men, they produce milk in very rare conditions, like things like sometimes men can get breast cancer. It's very, very rare, far more rare than women. But that's one thing, like all of a sudden male starts lactating. It's like, okay, let's take a look and biopsy of that mammary gland because that's not supposed to happen. But yeah, so, or even like when newborn male babies, I think sometimes it's colloquially called witch's milk. So males can lactate, but under a very, very strange condition. Yeah. We actually covered that next semester, so I have more about that coming up if you're hanging around for PHYL 142. All right, ceruminous glands. So these are very special glands, and where are they located? Well, this is a cross section of the ear. So we're seeing a frontal section and the ear hole, the ear canal. So this is the external auditory canal, and you produce cerumen. So cerumen is the medical term for earwax. So that's the whole purpose of earwax. It kind of makes it, well, depending on the type of earwax you have, but it helps it, or it's always a debate like, okay, do you actually need to clean your ears? Well, due to your natural jaw movements and daily life, like actually the earwax in your gradually works its way out. Maybe you can clean out this surface, but they often don't recommend using a Q-tip because that pushes it back in the wrong direction. But there's actually two types of broad categories of cerumen and earwax. So what we see here on the right is dry earwax, but some people have wet earwax, so they don't come off in flakes. They actually stick to a Q-tip if you did swab it that way. And the cool thing is so the wet earwax is sticky and smelly, and the dry earwax is flaky but typically odorless. I don't know who goes sniffing their earwax, but there is a reason behind that, and it's linked to what we just covered. So the cool thing is that this is due to just a small nucleotide change in one of the genes in your body. So it's due to just a change of one nucleotide in the ABCC11 or ABCC11 gene. Now the thing is that people with 1 or 2 copies of guanine at this position 538. So if you take the gene and count every nucleotide at position 538 from the start, you either have a guanine or adenine. So the people who have guanine there, they have wet earwax. The people with 2 adenines, instead of having guanine, they have dry earwax. So the cool thing is that it's also linked to apocrine glands as well. So the people who have like this wet earwax, they have more active apocrine glands that produce that sticky, wet, and smelly sweat. But the people who have this 2 adenines and dry earwax, they don't produce the same compounds and substances found in the apocrine glands of people who have the wet earwax. So they tend to have less body odor because they don't produce those sticky and smelly, or compounds that are sticky and smelly and can be broken down into smelly products. And the cool thing is that it's also linked to genetics, and different populations have different frequencies of these wet or dry earwax. So what we have here is A or G, so adenine or guanine. And the countries and regions that have yellow, this is where you tend to find the dry earwax. So this is very interesting. Like South Korea, like almost 100% of people there have the A. So it would be very rare to have wet earwax in South Korea. In Japan as well. And so the areas that have the dark blue, this is where you typically find the wet earwax. So it's kind of funny, like I have wet earwax, so I have like that. So I have at least one copy of the G gene. So if you've ever been to like Japan, I haven't been to South Korea, but if you've ever got to like try to use the deodorant from Japan, you notice that it doesn't work as well. And you can and like if you follow people like J vloggers or people who like going to, or expats who live in Japan, they say the deodorant doesn't work as well. And why is that? Well, if their deodorant is formulated for people who have less active apocrine glands with fewer of the smeller compounds, and because you see more of that dry earwax and that less smellier apocrine gland secretions compared to people who are from the US and other countries. Yeah. So if you have wet earwax, you probably have like the smellier apocrine glands than somebody who has the dry earwax. So again, this is why the expats always say bring your own deodorant if you're coming from the US to Japan and doing the JET program or something like that. But it's also showing you human genetics can vary, and I think this is a great example of how you go from molecule, and then you go from your cells and the type of cell secretions to tissues that produce these secretions, and leads to overall things. So even just one small change in a gene can cause a big difference in activity. And if you're to do that, if you're like did one of those DNA tests like 23andMe, they also tell you whether you have that wet or dry earwax gene. Okay, so what did I highlight over here in this? Let's talk about another function. So this is sensation, and what I'm tracing out here are nerve endings, and we talk more about nerve endings in the unit 3 of this class, but for now just know that your skin has a lot of endings that send signals to the nerves in your body. So if you haven't encountered if you just moved to Hawaii and you haven't encountered this, eventually you'll encounter this sooner. It's not if, it's when. But you're sleeping, and then all of a sudden, what happens? In the middle of the night, you feel something go across your skin, and then wakes you up. So if you, I mean, if you ever had this happen to you, you know what a cockroach feels like, right? But how do you know what a cockroach feels, legs, those tiny, prickly legs feel, compared to your bed sheet or some other thing like your pet that brushes up against you during the night, or anything else that brushes up your skin? Well, same thing. That here's another example of why your skin is so sensitive. And it can not only detect types of or where you have these sensations, but also different fine details as well. Yep. So here we have Braille, and I mean Braille. If you ever seen an example of Braille, very tiny, but these people who can read Braille, they're able to use their very sensitive nerve endings in their fingertips and detect the actual shape and read pretty darn quickly. I'm pretty amazed with that. But this is why our skin is super sensitive, and this is why we have all these nerve endings. So we can kind of tell where something is, the shape of things, and it's also very important. I mean, this is, even though we're sleeping, this is why we wake up, because our skin has all these nerves. Yeah. But okay, and the time we have left, let's talk about skin pathologies or diseases of the skin. Now, I can't cover all skin pathologies, and actually dermatologists, they have this whole language of ways to describe different types of skin diseases and what we call lesions. Or lesions in general are what we taught in, I mean, regardless of where they are on the body, it's like some sort of injury or something abnormal on the body. So skin pathologies, well, we did talk about one skin pathology, and remember that ultraviolet light, it has energy, and when it encounters chemicals, what can it do? It can break the bonds between chemicals, right? Or atoms. And we covered when we talk about tanning and also why it's important to wear sunscreen. This is what we have here. So we have those melanocytes, they produce that compound melanin. And remember that melanin is a chemical, it has bonds, but the melanin produced by melanocytes, this helps to absorb the energy from the ultraviolet light and protect your DNA and things like collagen and elastin from UV light breaking the bonds in these chemicals that you need for your skin and your cells. Now, there's other things that can happen. So there are skin cancers. So say these UV rays or something else causes a lot of DNA damage in the cell, causing it to become cancerous, and the cell doesn't undergo apoptosis. Well, then two types of skin cancers are squamous and basal cell carcinoma. So with squamous cell carcinoma, what we have here is it looks it looks like an open sore, right? Very ulcerated, and sometimes it's less common than this related skin cancer or another type of skin cancer called basal cell carcinoma. But what we have here is that, this is one you definitely want to get checked out, especially if you have it. It looks like a wound, but this isn't going to heal. It's going to stay like that. And the thing is that with cancers, you want to get treated early so it doesn't spread to other parts of your body where it's harder to treat and harder to get rid of those cancer cells. And this kind of scaly appearance and this ulcerated looking kind of lesion, this is what we call actinic keratosis, and this kind of looks flaky and open and kind of nasty, right? And then basal cell carcinoma. So what we have here is that compared to this open looking and this kind of raw looking squamous cell carcinoma, notice that's kind of it kind of keeps it intact, and it has kind of pearly look, and it's kind of pinkish, it's kind of swollen, it has all these blood vessels. Of course, this is how it looks if you have not too much melanin. That's why I'm eager to see that doctor who is trying to show what what skin pathologies look like in people who have more melanin in their skin. But yeah, this is what it would look like in someone with fair skin. But this is the most common skin cancer, and the cool thing is that, or not cool thing, unlike squamous cell carcinoma and other types of skin cancer, it has a low risk of spreading. So even though it's growing and it's kind of having this little small tumor here, it's typically benign and doesn't spread. And which stratum do you think it occurs in? Well, for the sake of time, we don't have a question for that. We'll skip the top hat question for that. But hint, what stratum of the epidermis also has basil or something that sounds like basil in it. Maybe the strand basal. So the cells that grow, so if one of those cells over there becomes cancerous, it can end up with basal cell carcinoma. So the cool thing about that is that even though it's the most common skin cancer, it has the low risk of spreading, means that it's easily curable. What they do is like, okay, they say, oh, it's basal cell carcinoma. So what the dermatologist might do is take a circular scalpel and just cut it out, and they tell you they cover it up and tell you how to what's the aftercare and how to promote the growth of the healthy skin over that. And you typically don't need chemotherapy or anything past that. Like they look at that they send it to pathologists. It typically stays in place. So if you got the cancer out by scooping it out, you're good. So yeah, if it was guaranteed that everyone would develop cancer during their life, and you could choose which type of cancer you would get, it would be basal cell carcinoma. So it's a very survivable. People rarely die from basal cell carcinoma. But a deadlier type of skin cancer is melanoma. So melanoma, sounds like melanin, right? And melanin is produced by melanocytes, and that's not coincidental. So this is the deadliest form of skin cancer. And if you talked about like, okay, how many people die from different types of skin cancer, this is the deadliest one. And if you were here for the last class, you might remember that our case with Sam, and the dermatologist say like, tanning beds increase your risk of skin cancer. He was like, she's going to develop skin cancer over her lifetime. So this is why it's like you want to protect your skin against all that UV radiation. So the good thing about is that if you detect it early, it's very curable. So only 2% of people who develop melanoma or early stage melanoma die after 5 years. But if it starts to spread to these, so we don't talk about lymph nodes in detail until next semester, but there are parts of your lymphatic system, and it's often a common site for cancer cells to spread and hang out in. So if cancer cells go past that initial melanoma and go into your lymphatic system, then survival drops to maybe like, okay, 2 out of 3 people survive. And then at very poor survival if it actually starts to spread or metastasize. So this is why melanoma is very deadly and why it's very important to catch it early. The earlier you catch it, the more likely that someone will survive. So this is why you might hear the ABCDEs of skin cancer. So this is what we have. I'm going to teach you the ABCDEs of melanoma. And what we have here is a benign. So this looks like a basal cell carcinoma, but what we have here is asymmetry. So notice that it has this kind of like raised part right here. And this part right here, it doesn't have as much of a border, and it's lighter color. So this means like, okay, it's probably malignant melanoma. Border, is the border very clear, or is it kind of faded and kind of looking like a watercolor painting where you have some like light spots, some dark spots? So you want, if it's like this looks like just a regular mole right here. And color, so I mean, people think like they see a mole and they're like, oh my god, it's melanoma. Well, these are again clear border, and the color is uniform in this mole over here. But this malignant melanoma, we see like, okay, there's some like kind of light spots, some dark spots, some reddish spots, some black spots. So if there's multiple colors, that's a warning sign. And diameter. So do I want you to know exact numbers? But I've heard the good rule of thumb is kind of like the head of an eraser, of the diameter of an eraser on a pencil. So that's like, if it grows bigger than that, that's kind of a little big for mole. So that's why. But again, there are some moles that are bigger than the eraser on a pencil. So don't worry, or just get checked. And then evolving. So is this something that has all of a sudden appeared and starting to grow over weeks, or is this something that you've had over like, and maybe it's grown 1 millimeter over 10 years of your life? So if it starts to change rapidly, like in the matter of weeks or days, and actually like in 2019, I had a skin cancer scare because like, I should actually put up the pictures, but I actually had a spot that grew like within months. It started small and then it started to grow big, and then got checked out. Thankfully, it wasn't malignant melanoma, but the dermatologist says, hey, let's cut it out anyway because it was growing way too big to be, or like the rate of growth was concerning to her, so that's why she cut it out. But hey, again, if you catch it early, then no problem. And she said she sent it to pathologists. They looked at it and they said, no, it's not melanoma. So I'm like, whew, bullet dodged. Okay, so protective properties of skin. So again, skin is a very important barrier, and not only against and it's not just a water-resistant barrier. It's also important in protecting your body insides from the outside. And yeah, ooh, what do we have here? This is I don't think I saw this during the Olympics, but I heard like marathon runners, they often use Vaseline on their nipples because if all that friction rubbing, eventually if you rub it too much, then that's going to rub out the outer layers of the skin. And now he's ended up going to the inner layers where it's starting to bleed. And what we have here is a blister. So this is like what can happen if you have damage to the epidermis or the separation between the two layers. So why do we get blisters when we run or do a lot of walking or rub some surface of our skin repeatedly? Well, this is due to fluid accumulating between the epidermis and dermis. So this is what we have here with a blister. So it's not due to, it can be infected, but typically it's just your extracellular fluid building up between the layers of the epidermis and dermis. But again, why does that happen? If you rub the epidermis and dermis enough, eventually they can start to detach the junctions that hold it together. So if you start to detach the two layers, fluid can build up, and that's why we get blisters. And another pathology. So what we have here, decubitus ulcer, also known as a bed sore. So how do bed sores develop? Well, where do they commonly develop? So if you're at home, try to feel the back of your head. Feel your shoulder. Feel your elbow. Feel your tailbone. How about your heel? Now compare the skin there compared to the skin like on your arm, or on your cheek, or on your chest, or on your stomach. Notice that all these points here, they don't have they're not very thick in terms of their skin and hypodermis. So how do bed sores develop? Well, it's due to those areas we just covered right now. They're kind of bony, right? They don't have as much like meat or fluff, or the skin doesn't feel as thick there. But what happens is if they have very low subcutaneous fat and not too much dermal tissue, what happens is that if you have there's this very thin layer of this bone between the bone and the subcutaneous fat. Well, if you have this between a hard surface, it can actually pinch off the blood vessels in that area of skin. If you pinch off blood vessels, what do? You deprive that surrounding area of blood. You deprive that area of oxygen and nutrients, and your cells need oxygen and nutrients to survive. If you're pinching off blood vessels, what happens to cells? They start to die off. And this is why if you've ever been a CNA or interested in nursing, this is why they have to rotate patients, because you kind of want to help to relieve the pressure from all this bone pressing against a hard surface. So you want to restore blood flow so you don't have the cells dying in these bony spots of your body. I know it's like a lot of gnarly looking things right here in this lecture. And I'm going to try to cover, if you have another class to go to, please go there right now. I want to cover burns as the last part, so I'm going to try to make a push to talk about burns. Okay, so what we have is a tissue injury. And what happens and the thing is that your skin is a barrier. It's not just a barrier against water, it's also a barrier against things like bacteria, viruses, or any other sort of things that can enter your body and start to take advantage of all the yummy blood and nutrients in your body and start to divide and infect your body. So what happens if bacteria enter a skin wound and they invade the immune system? Well, things that your skin does have some immune cells, but if you're very sensitive, look away. But this is what we have here. You might have heard that term flesh-eating disease, or what the more medical term is, necrotizing fasciitis. So what we have here is that in this case we have bacteria entering a wound, and the body wasn't able to, and medicines weren't able to clear that wound of bacteria. So the bacteria are dividing, they're released, and bacteria are unlike, if they enter and they're not cleared by the body, they're kind of like unwanted house guests. They create waste everywhere. They eat your food, and they start to cause the surrounding cells to die off. So they're like the worst neighbors ever. They're toxic, and they eat your food, and they make the whole environment very caustic. But fortunately, in the epidermis, you have these cells called Langerhans cells, and what they are. So notice that. This is the stratum corneum over here, and here we have the stratum basale, and all of these cells over here. So these dark cells, these are Langerhans cells. They're not melanocytes. Melanocytes are a different type of cell. But Langerhans cells that we see here in this dark color, so they're kind of like your cell's immune, or part of your immune system, and they're kind of like in waiting. So say there is a cell, or bacteria, or something that wants to cause disease, well, these will help to gobble it up and tell the immune system, hey, we have this invader here, let's deal with this. There are other types of immune cells, but we covered that more in detail next semester. And last topic, again, sorry for running over time, but this is a pretty important topic, and I think it's a good way of tying things together, especially for the functions of the skin, so burns. So when we talk about being burned, we think about, okay, touch fire and you get burned. But there are other types of burns as well. So if you touch water, it's not fire, but still you have heat. So this is a thermal burn, like touching this very hot water that has a lot of heat and it's going to burn that skin and your cells. But you can also get chemical burns as well, or electric burns. Like if you have someone's electrician and they're not careful, and they cross it and they get shocked with so many volts and current. And sunburns, those are also considered burns as well. But different types of burns, but they affect the skin. Now, burn degrees, I try to find better images, but first degree burn, well, we have the layers. So again, epidermis going from superficial to deep. We have our epidermis, dermis, and hypodermis, right? So first degree burn is going to burn that outer layer, so that epidermis. So it does affect our skin, but it doesn't penetrate very deep. A second degree burn will go past the epidermis and touch the dermis, and that's what we have. So first degree burn is why we kind of appear red. It's due to kind of like, that burn on that superficial layer. But second degree burn, well, if you're going to damage these cells over here, especially the ones that keep your epidermis and dermis attached to each other, well, what's going to happen? These layers can separate, so that's why we often see blisters with second degree burns. But second degree burns, notice that we have over here a nerve ending. So most of the nerve endings you see are just below the epidermis, or they're also contained within the dermis. So this is why second degree burns tend to be very painful, because you have all these nerve endings here at either the border of the epidermis and dermis, or contained within the dermis. So you're affecting more nerve endings. So this is why second degree burns tend to be very, very painful. Or they tend to be more painful than first degree burns. And third degree burns, so what we have is that now this goes even deeper. So it's going all the way past the dermis and now to the subcutaneous or the hypodermis. So third degree burns, this is why you see charring over here. And you might be like, oh wow, you burned the most amount of tissue, so it must be the most painful. Well, the thing is that these burns are so bad, you pretty much burned off these nerves. And if you burned off these nerve endings, you can't feel it because these neurons are burned off. So if these neurons are burned and their endings aren't working, they can't transmit pain signals to your brain. So this is a key difference between third and second degree burns. You burned it so bad that the nerves can't even do their job. So devil's itch. Look that one up. I'm not familiar with that. Oh, and I love this image like from Wikipedia. So what we have here is like it's showing you the layers are technically correct, but look at this part right here. This yellow stuff right here is, I'm assuming that the yellow is supposed to be subcutaneous fat, but where do you find subcutaneous fat? It's not in the dermis. You find it in the hypodermis, right? So again, this is another reason why, and I think this is my third year pointing it out and it hasn't changed. So again, it's like showing you Wiki is a good at a glance review, but at the same time, it does have anybody can contribute anything, and this is why you shouldn't rely on it as a primary source, because again, sometimes these errors go unnoticed. Okay, so first degree burns, again, it's very superficial. You're having the epidermis affected. Second degree, it starts to go past the epidermis, and then once you have third degree, this goes past all the way past the dermis, so complete dermis burn, and then to the subcutaneous. Now, do I want you to know fourth degree, where it's actually all the way past it, so it's not just the subcutaneous being touched. You burned off the subcutaneous as well, and what's below that, you see muscle or bone, and there are like some textbooks, they have fifth degree and sometimes even sixth degree, but it seems to vary depending on the source and authority, depending on what those are. So I just want you to know the first 3 degrees. So first degrees, again, the outermost superficial layers, and then second degree, you have some penetration into the dermis, and then third degree all the way past the dermis. Now keratin. So remember, throw back to keratin. This is what we found in our stratum corneum, and that starts to develop as the cells get pushed up from the stratum basale to the stratum corneum. And remember, that's water resistant. So the thing is that not only does it keep water out, it also keeps water in. So what happens if you have a really bad third degree, second degree, or third degree burn, but especially with third degree burns, what's going to happen? Well, the thing is that you burn through all that keratin, and that keratin was helping to keep water on the outside and also water on the inside. So what we see is that, okay, so this is all the vitamins, or not vitamins, the functions of the integumentary system we covered. So what happens if someone gets really bad burns all over their body? Well, they're going to definitely have a decrease in vitamin D, because the skin is a major site of making vitamin D. But you also you're more vulnerable to infections and water loss, because again, skin keeps water out, but also keeps the water inside of your body. So it prevents, if you didn't have your skin there, a lot of the water would evaporate. And that's what we see in victims who have burns. You have to protect them from losing even more water, because if that part is exposed, any water that ends up in that area is going to be lost to the environment with evaporation. So this is why you typically need to give them like an IV or something to rehydrate them, because they lost water due to the burn, and they're going to lose more water. And it's also why you want to keep that wound very sterile, because if you got rid of that outer epidermis, you also got rid of the Langerhans cells, and you also expose those tissues underneath that don't have the keratin. So this is why you have to keep it not only hydrated but also clean. You're also going to have a loss of sensation because of, especially in third degree burns, because of all those nerve endings. You're also going to have impaired temperature regulation. So say someone was burned and they're in a cold environment, like they fell into a fire in a campsite. Well, they're going to be able to they're going to be more prone to loss of, or have trouble like regulating temperature in the area that was burned. And blood flow. So if you're trying to deliver drugs or like antibiotics, would IV work really well in getting drugs or any sort of pharmacological agents to that area? If you don't have blood flow, then you're not going to have efficient delivery of that. And also lack of glandular function. So they're going to have trouble, again, this goes hand in hand with temperature regulation, but also with secretions as well. So they're going to have dry skin in that area. So this is why wound care is very important for people who experience burns. And this is a nice to know thing. So I think especially if you have experience, like I think they cover it in EMT school or in nursing, you should know the rule of nines. And it's basically a rule of thumb of trying to estimate how much of a person's skin is burned. And what we have here is that notice that all of these are multiples of 9, and there are so the entire trunk or the front of the body is 18%. The entire back is 18%. The whole leg is 18%. The whole leg is 18%. The head and neck together, both front and back, is 9%. Each upper limb, each arm is 9%. So you might be like, okay, that adds up to 99%. Where's the last 1%? So the last 1% are the genitals, and more specifically the perineum. So this is the area, so that's what it's referring to, that genital area. So, and In children, it's different because, again, children, their head are proportionately big compared to the rest of their body. And some of these things change, but what they do is basically take 9% and distribute it to the head because, again, kids have, this is why sometimes they're walking around, they hit their heads on things because they have that huge head compared to their tiny little bodies. Don't worry too much about the pediatrics because it also changes with age as well. So depending on which stage of development they are, if you're into pediatrics, you can study ahead, but don't worry, I won't cover pediatric rule 9s in this class. But for a starting point, you should know head and neck.